I'm Sebastian from Sebastian Simon's Mathematics, and today I'll be teaching my students and you guys, if you're participating, in the scientific notation and powers of two lesson in like an hour and 40 minutes, well, no, 83 minutes. So, okay. So, just as a reminder, you need to have a number that is like less less than 10 but greater than 1. Okay, so let's like this lot. Must have a base less than 10 but greater than 1. Okay. 3, 42, 3. Okay, good. Okay, so you must include 10 to the power whatever number stands out to the number. Okay, so let's do an example of scientific notation. So first, estimate 1,653,200,000. That number in scientific notation. Okay, so already 2 minutes in. Bing. Huh? Yeah, we're already 2 minutes in. Bing. So make sure that you like and subscribe. And make sure that you like and subscribe to my channel. Okay, thank you. So, how can we estimate this number in scientific notation? Well, we could count how many zeros it has for that number that's on my whiteboard right now, and calculate how many zeros it has, and calculate its full value. Because you must include all the numbers on a thing. Okay. Speaking of which, okay, so we're gonna count all of the zeros. So, like, how many zeros do you see? Like, a lot. I bet. So, I count the zeros, usually by 3 values. So, 0, 3, 6, 9, 12, 15. 15 zeros. So, this number equals 1.6532 times 10 to the power of 15. Or nothing. Okay. So, speaking of which, make sure they comment down below if you are wondering about this. So today we're going to be doing scientific notation and then doing powers of 2, like squared numbers, like to the exponent of 2. So like, speaking of which, this is scientific notation right here. Okay. 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 Here's a number that's already in scientific notation. Estimate 3 times 10 to the power of 8. Okay. So I calculate how many zeros it has. So starting at 1, 0. Making 2, 0. 3, 4, 5, 6, 7, 8. And we stop there. And then we added 3. See? That's what you use standard form and in scientific notation. So this is going to be what scientific notation is all about. Scientific notation is about exponents, powers of 10, and so much more. I can't even imagine. So, speaking of which, do you want to try it? Okay. I'm going to give you like a couple minutes. Okay. Scientific notation. Like order. Okay. So estimate all of this and some of the numbers already in scientific notation. Okay, so problems 3 and 6, you need to find the number in scientific notation. But remember, it's not going to be less than 10. Well, it's going to be less than 10, but greater than 1. Okay? You have 5 minutes to work on this. And then if you're all familiar with the scientific notation, then we are going to move on to another lesson already. Oh yes, there's going to be a word problem too. Yeah. Okay. Actually, we're just going to give you like 1 minute to work on all of it. So, do you want to actually work for this after class? Okay. We're going to be going over this thing as a class now. So, this is equal to 30,000. Then 4,500,000. Then 1.003 times 10 to the power of 5. And then 3,470. Then 340. And then 3.4749356 times 10 to the power of 8. Okay. So thanks for watching. I hope you have a really good day. I'll see you in about 15 to 20 minutes. But it's going to be the same class, okay? Bye. This is probably going to be my last live for today or something like that. Yeah, my last live for today. Because I've already taught Algebra 1's morning period for today. Yeah, for today. So speaking of which, if this is going to be my last live for today, maybe not. So, yeah. Okay. Okay. So, okay. So today, I will be teaching you in the whole class this. So x squared. It's like whatever number being squared. So, like, let's see. Turn and talk to your neighbor. Why am I writing these numbers? Ready, set, go. Okay, so we're already 3 minutes in, and I am going to be okay, so my next geometry lesson will be tomorrow, I believe, which we'll go over lesson 7.5. Okay, so today is a B day. This is 4th period, 8th grade mathematics. So, 2nd semester. So, okay. Okay. So, if you have any questions, comment down below. And if you need to talk to me, comment down below as well. And also, please like and subscribe. I need to get to 300 subscribers. Yeah, 300. So, guys, we're going to be going over this now. Yeah, only go back on weekends. So, I wrote all of these down just so that we could go over what it's this number by itself is. So let's start. 1 squared is 1. Any number to the power of 0 is 1. Or 0, 0. 0 to the power of 0 is undefined. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. Eleven squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. 15 squared is 225. 16 squared is 256. 17 squared is 289. 18 squared is 324. 19 squared is 361. And 20 squared is 400. So why isn't 20 squared 200? Well, what's 1 squared? What's 4 squared? Or 2 squared? Okay, so 2 0 squared is 400. Correct. Well, can anyone tell me what 30 squared is? 900. And then okay. So every single time that we have these zeros, you always add 2 zeros. Like, for example, 90 squared is 8100. Okay. So I'm going to have you make a project today and tomorrow, or today, like today. You guys are going to be finding the square numbers from 1 to 100. Yes. Okay. Tomorrow and the day after, or tomorrow, we're going to be going, tomorrow we're going to be going over cubed numbers and then quadruple numbers. Okay, so powers of 3 and powers of 4. First comment of the day. Wendy K. Dinley. Hello, teacher. Hi, Dinley. Okay. So, speaking of which, I was like this up, class. Okay, so here's going to be the agenda of next week, class. So, today is April 25th. So, April 26th, which is 20, which is on okay. Sunday, April 26th. April 26th. April 26th, we are going to be doing cube roots, cubes, and powers of 4. On Tuesday, I think we're going outside for this. April 28th, we're going to be going over to the power of 5, and the powers of 6. On Thursday, April 30th, we're going to be going over the powers of 7 and powers of 8. And then on Saturday, which is May 2nd, it'll be x to the power of 9 and x to the power of 10. Just as a reminder, why don't we do x to the power of 1? We'll see, every number to the power of any number that doesn't have an exponent has the power of 1. Casey Summon. Hi. Okay. So that's it. So today we're going to be doing the powers of 3 and 4 tomorrow, and then 5 and 6 on Tuesday, 7 and 8 on Thursday, and 9 and 10 on Saturday. Okay. Thanks for watching. Make sure that you like and subscribe, okay? Have a good day. Bye. Today, me and my 7th grade mathematics students are going to be reviewing what mean is, what mode is, what median is, and what range is. So, class, today we're going to be reviewing mean, mode, median, and range. Yeah, I have every single class's scores, but we do have an assembly riddle today. So, the assembly, it's the end of a quarter assembly. And speaking of which, for quarter 4, we're gonna for quarter 4, we're gonna do like this attendance challenges. I think that was what it is. Okay, so today we're gonna be reviewing mean, mode, median, and range. You guys are gonna solve 15 problems that I write on a board later in class today, about what mean is, about what mode is, what median is, and what range is. And so, why are we going to review what we have learned? Well, reviewing what we have learned is good, practically. It's practically just like learning what mean is, learning about what mode is, what median is, what range is. Mean equals average, okay? Mean equals average. So why does mean equal average? Correct. So we're gonna write down these words one more time before we do the review game on oh shoot. Tomorrow I have a sub. Well, yeah, tomorrow I have a sub. I forgot to explain that to my last class too. But you guys only have a sub for like a little bit. But you guys only have a sub like half a class. Half the school program. Okay. So, we're reading mean, median, mode, and range. So, why are we worrying about these words again? Okay. 17. Okay. So, yes. So we're going to be writing down what the words mean one more time before we do the work worksheet. Before that, does anyone have any questions before we move on? If so, then comment down below. Okay. So, mean, mode, median, and range. Oh. Wait. Extreme YTXT. Hi. Okay. So, speaking of which, we're going to let mean, median, mode, and range. So we're actually going to go through that right now. So mean practically equals average. So mean is adding up all of the sums and then dividing it by the number of the actual numbers there are. Like for example, we have 10, 15, 20, 25, 30. We have five numbers. Okay, so we add all of these up, we get 25, 45, 70, 100. So we get 100 divided by 5 is equal to 20. The average is 20. So what if we do 10, 10, 10, 10, and 10? Would that change our average? Yes. It changes our average real quickly. So, speaking of which, yeah, I'm going to use a different color for the vocabulary word. Mean. Add up all sums. Add up all sums. And then divide by number of actual numbers. There are. So practically just like 5 numbers, or whatever. Okay, so purple cozy girl. This, and then this. What? Okay, hi. Hi, purple cozy girl. Okay, this is like crazy. So, the second vocabulary term is mode. Okay, so we have word over mean and mode in 7.1, and then median and range in 7.2. So how can we even explain what mode is? Well, mode is adding is a most number. Okay, so practically this. Okay, so mode is practically which number occurs the most. So, okay, mode is, ask yourself this, what number occurs the most? Okay, so in this worksheet, you will actually, okay, so I will solve 5 of your problems. 5 of your worksheet problems. Okay, so the last 5 are going to be like, pick this number of numbers, and like, write these many numbers, like this many numbers, this many numbers. That will be on the last 5 questions of your worksheet. And yes, I'll be able to solve all of them in a rare time. So, okay. So, median. So median is practically like, okay, so median is a middle number put in numerical order. Middle number in numerical order. So let's just say there are three numbers, 10, 49, and 55. 49 is a median number, or the middle number in numerical order. Okay? So range. So speaking of which, what is range? Yes. Okay. If you can see down here, that's great. So range is the highest or biggest number subtracted by. You should always subtract these numbers, or else you'll get a big, completely different answer. Minus lowest, smallest number. That is what you should be noticing for when you're finding the range of a number. Okay. Okay, so I don't think you could see me right now because of a Q&A. So, what is your hidden talent? So, okay. So, you guys will be doing a worksheet now because you'll be doing the worksheet now because I personally have method. Okay, so thanks for watching. Please like and subscribe. Bye. One moment. As I was saying, hi, I'm Sebastian Simon, mathematics. I'm Sebastian, a future math teacher. Okay, so as of right now, I teach geometry, well, high school geometry, Algebra 1, Math 8, and Math 7. So today, well, this is 5th period, my Algebra 1 students, so my Algebra 1 students are going to be finishing off the video that we're going to be watching today. So, okay. So, in a little bit, I'm going to show you what the chapters are. So, okay. So we're gonna label this section 7. Okay, so I'm gonna do this for like 20 minutes-ish because me and my class are gonna be doing the actual video part of it till like 1:15-ish. And then the rest of the class period, they're going to be doing study hall because it's the end of a quarter. Okay, what did I just say? Okay. So. Okay. So section 7 is exponential equations of quadratic form. Well, this is okay. Jamon Navokandawala 3822. Hi. Okay. So speaking of which, my algebra 1 students were supposed to learn quadratic form until they're in actual algebra 2, but I'm just teaching them the actual introduction to quadratic form of algebra. So, if you have any questions, make sure to comment down below, and let's get back to work. So, speaking of which, Christine, Jace, hi. Okay, so it includes the structure of it. So structure is A, B, and then 2x plus C, D, CB plus D equals 0. Don't forget the little exponent there. Huh? What are you doing on? Oh, sorry. I kind of forgot to tell you that. So today we're going to be finishing off our notes from a week to now. So, okay. Thoughts about JROTC at B YouTubes? Okay. A little. Sort of a minor distraction, but okay, so please hit the like and subscribe button. I really need to get to 300 subscribers. Literally, 300. So, here's the structure of it, practically. Okay. So, you might be interested. What? I might be interested? In what? Okay. So, the structure says let u equals p to the power of x, then solve quadratic, and then back sub to solve for x. Like, we need to find an x. Okay, so where did he go? Junior Reserve Officers Training Corps. You might be interested. I did not even notice the training corps or whatever. Okay. So here is an example. This is 7-1, example 7-1, or 71. Okay, so this is 2x plus 8. And then 5x minus 2o, no, 20 equals 0. So now it's just 5x 2 plus 8, then 5x minus 20 equals 0. Okay, it says let u be 5x to power of x. And now it says u squared plus 8u minus 20 equals 0. And then we need to like distribute something. U plus 10 and then u minus 2 equals 0. So, and now Bernoulli says u equals negative 10. But how can we check that to make sure? Well, 10 multiplied by negative 2 equals negative 20. And then 10 plus negative 2 equals 8. Positive multiplied by a negative is a negative. And then positive plus a negative equals positive, depending on what the number is for that number, and depending on what the number is for that. In that case, positive plus negative. Positive plus negative is positive. I do not know if that's true. So, okay. Okay. And also, in other terms, u is also 2. And that's only 5x equals negative 10. And 5x equals 2. This is what quadratic form is, practically. Okay. So we have 3 more sections to go. The last one was quadratic form. This one is compound interest. So I don't think this is racist. So okay, so now I'm gonna have to wait a couple minutes. Okay. Speaking of which, what is quadratic form? Turn and talk to your neighbor. Ready, set, go. Okay. Okay, only 8 comments. Okay. Okay. 1 person watching, 3 likes. Okay, good. Okay. let's do this. Section number 8 is compound interest. Well, what is compound interest? Okay, so we have 10 minutes left already. Okay, so we're going to have to speed things up a bit. Yeah. Well, that's why we're going to be doing sections 8, 9, and 10. Notes. 8, 9, 10. Word problems. Okay, so for the last 3 sections, because today is the last day of their quarter and the last day of mine, so here's the formula. Section 8. A and T equals P1 plus I over N to the power of N and T. Which is A is the future amount P is a principal amount, lowercase I represents annual interest rate, then N, number of times interest is compounded each year. One moment. I'm back already. And T is the number of years. Okay, so this is the formula for section 8. Okay, section 9. Huh? 14. 4 lines. Good. Good. Okay. So speaking of budgets, here's the formula equals E equals lim over lim and then infinity. I do not know why they're planning up this stuff. Then 1. Then L plus 1 over N. And then 1, I think. Because approximately equal to 2.71828284845 E, and you know what E stands for? Earl's number. EU Euler's number is rational, just like pi. Pi is 3.1415926535589, but Euler's number is 2.718281828459. Like, both of the numbers are irrational numbers. So how can we estimate Euler's number compared to pi? And speaking of which, here is the last section. Section 10. It's already 1:10, so I think we have enough time. And this last one is a derivative of exponential functions. So, d divided by dx bx equals bx ln b. Well, we're not going to go over all of this. We're not going to go over the examples today. We're not going to go over everything today until Algebra 2. Okay? So, okay. Thanks for watching. This is my, okay. So this live is my last live for the lessons 6.3 and 6.4. So this is my last video. But not my last live. Not my last video. Yeah, I'm still gonna keep going. Yeah, I'm gonna keep going until I die. And speaking of which, please like and subscribe. I need to get to 300 subscribers. And then I'll extend my goal to 350. Like and subscribe. Bye. Before we get started, today is May 1st, 2026. And speaking of which, it's the first Friday of this is the first day of May. I'm wearing pink because May 1st this year is on a Friday. And generally speaking, next week I'm also going live. Wait, never mind. I didn't mean to say it. So next week, January, I am going to be putting my talent show on live. So, well, it's not going to be on live, but I don't know. So, speaking of which, today is May 1st, 2026. In 9 days is Mother's Day, followed by 24 days will be Memorial Day, I think. So, only one person's watching me right now. Okay. So, generally speaking, I am going to be teaching you all parts of similar triangles. Yes. towards that. Sorry. Huh? Can you sing the song you're gonna sing at the talent show? Okay. The music video is gonna be posted on YouTube tomorrow. Well, it's actually gonna be posted on Sunday, but I'm gonna be performing it on tomorrow. Not during my live streams, okay? Not during my live streams. Okay. So, speaking of which, I am at 270 subscribers currently. So I need to be able to get to 300 subscribers. And speaking of which, okay, never mind. Let's get to work. Okay, let's get to work. Okay. 8 people are watching me right now. Yeah, I couldn't even see the number. Because I was like, oh, my light was the main reason why I do it. Well, the works. Okay, hold up. Hold up. Okay. So I'm just gonna say, I do not remember anything before 2018. Except for a fact that George W. Bush died on November 30th. But why am I even talking about this? I should be talking about mathematics. Not singing. Thanks. Yeah, I was distracting you. Sorry if I am. So, speaking of which, this is lesson 7.5. Okay. So, speaking of which, I have two. Speaking of which, wait, yeah. Just doing this based off my standards. I would never tell you a secret. Okay. Yeah, no, none of you are gonna tell my secret. The CBA. Yes. And if you all know, geometry has a lot of algebra to it. In my last, in my 15, I think, I would deal with so much algebra that I really want to quit the live stream. So let's get to work. H, J, G, F. Why didn't I add I? Well, I represents a number, but I don't even know what number. Okay. So, one person, one mic. Okay. So, okay. So this is practically like what? TB man. Hi. Okay. So this is so if you have been in physical science before and if you're learning about learning compounds, it's not like 6 carbons and 8 oxygens and 22 hydrogens. It's practically like this. M80, which is line 80, divided by line FG, is equal to line MAC divided by FH, I think. Jack. Oh shoot. Hold up. Jack UF. No, Jack U 5F7P. Say hi. Hi. GB McMahon. What are you doing? Oh. What am I doing? Today we're learning about parts of similar triangles. If I underline a title, that means it's the title of my live stream. Back to Quake. That's not really related to the live stream. It might not. Jekro Fry Bag. What the? Hi. This man looks nice. Yeah, kind of nice. So, back to Quake, speaking of which, is equal to AB divided by MFG. Yeah. What? This was supposed to be FJ, not FG. Sorry. Sometimes I learn from my mistakes. Okay, so this is probably an example. Okay. So with this, whatever term it is, right. This is probably similar segments of similar triangles, but it says if two triangles are similar, the lengths or corresponding altitudes are proportional to the lengths of corresponding sides. Speaking of which, who even knows what the similarities of bits are? So, if we take this for geometry, let's say this is 90 degrees, and then this might be 45. This might be 45 degrees, and then if that equals 45, then this should equal 45, because the interior says that you need to have that it needs to add up to 180 degrees. This is also a right angle. This is also a right angle. This is 45. This is 45. This is 45. This is 45. It does not even matter where on earth you practically got this stuff. So this is geometry. My first school year teaching geometry. Yes, I teach Algebra 1, I teach Geometry, I teach grades 7 and 8 math. So, this is only my first potential school year of teaching. Well, I teach home, practically. So, M80 divided by MFG equals MAC divided by MFH equals MAB divided by MFG. This is much better than what we were. So, okay. So, just checking. So, let's get going. Okay. So here's the thing that might surprise you in any way. So I'm gonna have to back this whole thing off, because sometimes it likes to stick, sometimes, so I'm just using Clorox on here. So yeah. Sorry, that was the bell. Okay. So, we have This is very horizontal. Okay. And then here. And then here. And then goes again. Here. 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 One of them is large. One of them is small. Wait. Which one of them is larger? That one or that one? Comment down the left if you think the left one is large. Comment down the right one if you think that's larger. So, to test this, we have to follow the similar segments of similar triangles. So, this is similar. So, what do you mean it's not similar? This doesn't even look similar at all. But does it include size? I don't think it includes size. It includes the angles of it. So why are we just learning triangles in geometry? Well, geometry is all about triangles, okay? On Sunday, I think, I'm going to be switching this thing up to the Pythagorean theorem. Then after the Pythagorean theorem, we're going to, Pythagorean theorem, sorry. After we're done moving from the Pythagorean theorem, we're going to move on to 7-6 on Friday, next Friday. Practically, because I do 2 lives of the same class, maximum. So, does this even include anything that deals with triangles? Yes or no? I think it does. So, break over 1, 2, and then 1, 2. And then we have 1, 1, 1. So which is larger? Left or right? Okay. So we're gonna do Q, T, S, if that's S, R, then K, L, M, P. Okay. So those 2 angles are similar. The lengths of corresponding angle bisectors are proportional to the lengths of the corresponding side. So, here is the practical equation. So, MRT, this is R to T, is this line down here. So, I'm going to mark this line using purple and pink, because purple and pink are terms for this geometry. So, RT. If you can't see the pink, sorry, but I think you might have to either zoom it in, or I'm gonna have to download it and share it to you. So, and this is LP. LP. So speaking of which, they both go on the same fraction. So RT divided by MLP equals MRQ divided by MLK. Oh. Okay. And now that would equal MRS and then MLM. Yeah. Okay. So one of these two, so they all should equal to each other. So let's say you get a final answer of 5. Then the other two should equal to 5. Then the other should equal to 5. So 5 equals 5 equals 5. Like one huge equation. So why don't we balance out the so why don't we balance out 5 equals 5 equals 5 as an example? Why don't we just do 7 equals 7 equals 7? Whatever answer you get, it always has to be equal to one of those. Okay? It has to equal to one of those. So, being a birch, this is another one of those examples of terminology. Geometry. So, okay. So now you're going to do the lesson 7.5 proof sheet or something like that. So proof sheet. And you know what the proof sheet is? It's like this table with like 6, maybe 6 to 7-ish steps. So like you need to find out what this might do. And okay, what's step 1? So if you find step 1, then what's step 2? And if you know what step 2 is, what's step 3? Then step 4, then step 5, step 6, step 7. But this one, we're doing 5. So, cancel out boxes 6 and 7. And this is not one of those 6, 7 codes. So, okay. Generally speaking, okay. So the statement. Okay. So we're going to have to do 2 triangles. Like, bold. Okay. M, P, L, K, then F, G, H, no, H, J. Why do you think geometry equals algebra? Geometry has some algebra to it. That's what's going on. So, what do you mean this is what's going on? This is another one of these weird, crazy things. So on the left-hand side, the sheet always says statements. And the other one says justifications. Okay. So what is just So first one has to have the, okay, so what's the first statement? So the first statement according to this says, step 1, triangle FGH is congruent to triangle KLM segment FJ plus KP are altitudes. And what does that give us? Given. G-I-V-E-N. So, then the second. It says angle FGH plus angle KPM are root L's. It's like, what do those even mean? Okay, so it says definition of altitude. ALT means altitude, according to my language. So, okay. This one is part of similar polygons. Ow. Okay. So, section 3 says angle H. Or we're angles. Angles, not L's. I kind of forgot that it was angles. So, okay. Speaking of which, we are going to be doing like this thing. Angle H is congruent to angle M. And that's definition of similar polygons. What are similar polygons? What can you remember from a similar polygons worksheet? So, similar polygons are usually rooted to describe 2D shapes. So, for angle FJH is congruent to triangle KPM. And what does that give us? AA. Do you know what AA means? Well, I necessarily don't either. So, 5. And FJ, KP is equal to FH. Okay. And then here we go again. Definition of similar polygons. Okay. So what are we trying to prove here? This one over here. So, okay. So that's it for the algebra part of it. Well, not necessarily the end of the algebra part of it. We still have like one-ish example to go over. And that is the finding the x's. So, well, finding x. So, what is x? X means an unknown number in algebra. Okay. So, let's see here. 14, 6, 18. Okay. So we're gonna find x. So, speaking of which, it's 14 divided by 18 minus x, which is equal to 6, is equal to x. This is 18 here, x. Okay. So now we're down to 14x is equal to 6. Then 18 minus x. And then we actually have 14x equals 108 minus 6x. Okay. Okay, so we're gonna add 6x. So whatever you do to one side, we do to the other. Done. So now we have 20x equals 108. Divide that by 20. Well, we usually got x equals 5.4. So, thanks for 270 subscribers. And now I'm already at about I'm already over 900 likes. And over 102 and I'm already at 102 comments. That's just for my YouTube shorts, probably. So, if you enjoy watching this YouTube short, please like and subscribe, and I'll see you next time. Bye.